The next unit, torque protection network theorems, we have already seen how to reduce a circuit, or one method of converting voltage source into current source and current source into voltage, vice versa we can convert. And now we are going to theorems. The theorems in this case, we are going to see many theorems like Thevenin'S theorem, Norton's theorem, superposition theorem, reciprocity theorem, Millman's theorem, etc. etc. So these theorems, what it says, a complex circuit. If you have a circuit, a very complex circuit, bilateral circuit, linear bilateral circuit, where you got more number of branches, we can solve the circuit. Ultimately, we have to find current flowing through a particular load. Or ultimate aim of solving a circuit is to find the response. This current flowing through a particular branch. So for finding that particular current, particular branch current, what we can do, we can reduce the entire circuit into a simple circuit. So all theorems mostly say we are going to see Thevenin's theorem now. So Thevenin's theorem is applied for a bilateral complex linear network where that if you say, like I have shown here, this is complex network. This you can say it's a black box. You got many number of branches over here, and this is an open circuit end where you are going to connect our load here. Okay. So this complex network can be modeled or can be modified with can have any number of sources, any number of branches here in this complex, in this box. Okay, that complex branch with sources and resistance, more number of branches, can be modified into a simple circuit with a voltage source called Thevenin's voltage. Thevenin's voltage, and a resistance in series with it. You can see this your this complex network being modeled with V Thevenin and a resistance called R Thevenin. So now let us see how to find this V Thevenin R Thevenin. So the theorem states that any complex network, linear bilateral network, can be modified into a simple circuit containing a single voltage source called VOC or V Thevenin, Thevenin's voltage source, or open circuit voltage source VOC, and a resistance connected in series with that source called R Thevenin, Thevenin's resistance. Okay. Now let me show you how to find this V Thevenin and R Thevenin. Okay. So I have shown a simple circuit with the voltage source V and two resistors R1, R2 and load resistance RL. My aim is to find current flowing through RL. My aim is to find current flowing through RL. Let it be ideal. Okay. So I can, wherever we got load, we can mark that terminals as A, B. So current flowing between this A, B is our requirement. So how to apply Thevenin's theorem to this circuit? I told you, now this is your complex circuit. You can see this V and these branches forms a complex circuit, and this is your load point, output port. Okay. So I have to model this one into Thevenin's voltage and Thevenin's resistance I have to find. So now let us see how to find Thevenin's voltage. To find Thevenin's voltage. To find Thevenin's voltage or open circuit voltage. It's called open circuit voltage. Okay. So VThevenin, VTH. So now to find VTH, I have to redraw the circuit, removing the load resistance, and I have to keep that one into open. Okay. So now to find VOC, my first exercise is to remove the load through which current is required. Okay. So I have removed between the points A and B, and here we have to find V Thevenin or VOC. Now it is open circuited. The load is being opened. I have removed the load RL, so that now it is open. Now I have to find the voltage across this terminal A and B, and that is our open circuit voltage or Thevenin's voltage. Okay. Now how to find this open circuit voltage? Very simple to find here. Already we have studied how to get the voltage across resistance. Now if you take current starts flowing from here and flows like this. Since it is open now, no current will be flowing this side. So only current coming out of this voltage source will be flowing through R1 and R2. That is R1 and R2 are in series now. So now what is voltage across R2? Just by giving voltage division method, we can find VOC. So now we can apply VOC so that we can find voltage across R2, because voltage across is between AB terminals is the voltage across R2. You can say, just like you can see here from the circuit itself, you can see voltage between these 2 points is equal to the voltage across R2. So by applying voltage division method, we can find R2. R2 is equal to total voltage V into the same resistance divided by total resistance. So this is your V Thevenin. So we have to, our aim is to remove the load and keeping open, we have to find the voltage across that points. So in this case, it is voltage across R2. So voltage across R2 from voltage division method is total voltage into the same resistance divided by total resistance gives you V Thevenin. We found V Thevenin. And now we have to find resistance R Thevenin. To find R Thevenin, the next one is to find R Thevenin, we have to remove the sources in the circuit. For example, if you have voltage source in the circuit, we have to short circuit the voltage source. If you have current source in the circuit, we have to open circuit the current source. Then we have to look back from the open end and we have to find the total resistance. I'll show you how to find this R Thevenin. I can change the circuit like this. Since I have in this case I have voltage source, I short circuit this voltage source and I have left with these 2 resistance. So I have to look back from the open end. This is my open end. From this I have to look back. I have to find R Thevenin. So once if you look back, I have shorted V Thevenin, voltage source V, applied voltage V. If I have current source here, I have to open it. Okay, but here this voltage source is given. So I have short circuited, and now R Thevenin is simply, I can see at this point is within branch, so R and R2 is in parallel. So my R Thevenin value is R Thevenin is equal to R1 R2 divided by R1 plus R2 is my R Thevenin. Once I find R Thevenin, I can model my circuit into a simple circuit. How? So now I can replace the entire circuit as a simple circuit like this. V Thevenin, RDV found, P into R2 by R1 plus R2, and I have found R Thevenin. Now this is your Thevenin's. This is your Thevenin's equivalent circuit. Thevenin's equivalent circuit is this one. Now this is your point A and B. Now you can find current flowing through RL. So current flowing through RL can be found using the formula IL is equal to the net voltage applied is V Thevenin. So IL is equal to total voltage applied is V Thevenin divided by total resistance, because R Thevenin and RL both are in series now. So IL is equal to V Thevenin divided by R Thevenin plus RL. So a given complex network can be modeled into a simple one, so that it is very easy to find the load currents. Thank you.